Hi, everyone. Welcome to Lesson 6 of Unit 4. And so this lesson is going to take us on our next kind of section of quadratics. And we're going to start with looking at what's called common factors in polynomials. And polynomial is a term that we saw in grade 9. You guys may not remember this, but basically this is any equation that has three or more terms in it, and what we're going to be looking to do is pull factors, something that is common to each term, pull it out of it. And this is going to be very useful when it comes to quadratics. So we're going to leave quadratics for a little bit, just for the first part of this lesson, but we'll get back to it at the very end of the lesson, just to see what to show you where we're going. And actually, before we leave quadratics, I want to just mention this, is that we've been dealing with two different forms of a quadratic, two different forms of the parabola, the factored form and the standard form. And let's just kind of review that, is that a factored form would look like this. Y is equal to A times x minus r and then x minus s. Okay, and I could even write an example in here. Let me just write this one in there. Okay, so an example of one written in factored form would be y is equal to x plus 2 and then x minus 3. Okay, so that's a factored form. In this case, the a is 1. I don't have to write the 1 in there, but the a is 1. Well, that exact same parabola written in standard form, well, first of all, standard form looks like this. Y is equal to ax squared plus bx plus c. That's the way you would write it. And what we would do is that in order to go from factored form to standard form, we use something called FOIL. So you guys have learned FOIL. It's first, outer, inner, last. And so with this one, I would do x times x, and then you'd get x squared, and then you'd do x times negative 3. That's the outer. 2 times x is the inner, and then 2 times negative 3. And as a result of that, you'd get y is equal to x squared minus x minus 6. So those two parabolas are the same equation. They're just written in different forms. And we've learned that to go from factored form to standard form, we use something called FOIL. Well, again, for the next little bit, what we're now going to learn is how to go the other direction. So in other words, how to go from standard form to factored form. And we call that whole method, we call it factoring. So that's what we're going to learn. Now again, we're going to take a few lessons to learn how to do this, because it's a little bit harder than FOIL. So factoring is kind of the next migration that we're going to do in terms of quadratics. Okay, so here we go. Let's leave quadratics for a second and kind of learn some tools here that we're going to need. Okay, so first of all, this idea of the greatest common factor. Okay, so you've probably seen this before or heard about it before. And so what is the greatest common factor? Well, what it is it's the biggest number. It's the biggest number that goes evenly or divides evenly into two or more numbers. Into two or more numbers. Okay. So we're looking for this number. Now I'm going to give you some tools to do this. I have to admit, a lot of you probably the tools I'm going to give you are kind of a bit long, but what I'll say to you is you don't have to use these tools, but it's nice to kind of see them, and I think that you'll start to see why that, in many cases people can just find the greatest common factor by inspection, but it's nice to have a few tools to do it. Okay, so let's say I gave finding the greatest common factor with these two numbers. I said find the greatest common factor of 18 and 42. So what's the biggest number that goes into both of them? Now, a lot of students will say to me, well, I know 2 goes into both of them. And you're definitely right, they're both even, so you know that 2 will go in. But is that the biggest number? And so I'm going to give you this technique for doing it where you can be sure that you get it. So watch what I'm going to do. I'm going to write my 2 numbers here. I'm going to write 18 and 42 here. And now what I'm going to do is try to write 18 using only the combination of numbers that have no greater factor. So look at this. What I mean by that is I know that 18 is going to be 2 times 3 times 3. So notice that 2 and 3 don't have any factors other than 1 in themselves, and I don't have to worry about that. So that's 18 written with only what we'll call lowest factors. Okay, so watch this. I can do the same thing for 42. And some of you are saying to me, well, maybe even for the 18, you're saying, well, how did you get those? Well, I knew that 2 times 9 was 18. And I knew that 9 was 3 times 3. So you got to kind of work your way through it, but you can see that that's how you're going to write these factors. So look at this. When I know 42 is 2 times 21, but look, 21 can be written as 3 times 7. Okay, so again, just working your way through these numbers. So there you are. I've written them as a combination of factors that cannot be written in smaller terms. And then this is the key part. Look what I do. I look for what they share. So notice that each of them has a 2, and I kind of knew that because they were both even, but also each of them has a 3. And so I can pull that out and I can go, well, 2 times 3 is, oops, got ahead of myself there. 2 times 3 is equal to 6. So look, 6 is the greatest common factor. So it's the largest number that goes into both of those evenly. All right, let's try 3 numbers now. Okay, so here we go. Let's write 9, 15, and 27. Okay, so I'm going to try to write them as factors in their lowest terms. So I look at 9, I go, well, I know that one. That one's 3 times 3. 3 cannot be broken down any further, so there it is. Okay, 15. Well, 15 is 3 times 5. And again, those two numbers can't be broken down anymore. And then 27 is 3 times 9, but 9 can be broken down, so it's 3 times 3 times 3. Okay, so 3 times 3 times 3. Okay, so here I go. I'm looking for my greatest common factor. Well, I notice that they all have a 3, so I know 3 works. Now, remember, all 3 of them have to share it. So I'm looking for, I see that 27 and 9 both have another 3, but unfortunately 15 doesn't have it. And 15 has a 5, but the other ones don't. So in this case, the greatest common factor is just 3. So it may just be one number. So that's the greatest common factor between those. All right, well, let's start throwing some variables into this. And so it doesn't make it any harder, because watch what I'm going to do. I'll write my 3 terms. It's 36, it's 8x, and it's 64y. All right, so let's start by writing them in their factored form. So 36. Well, I know 36 is 2 times 18. And then, 18, though, is 2 times 9. and 9 is 3 times 3. Now you can write these in any order. So some of you might have said, well, I know that I know that it's 4 times 6, or sorry, 4 times 9, and then broken it up from there. So don't worry how you, like, it can be 2 times 3 times 2 times 3. Like, don't worry about that. The bottom line is, though, you have to get down to the end. So here we go. Let's try 8x. Well, 8x, well, let's work on the 8. It's 2 times 4, which is 2 times 2. And then look at this. And I know that my times here are a bit confusing, but look what I'm going to write. It's times x. I'm going to use a dot here just to show differentiate between the multiplication. All right, let's do 64. Well, 64 is going to be 2, and I'll use dots here just so that you guys can see this, times, well, 2 times 32. All right, so, and 32 is 2 times 32 divided by 2 is 16. Good. So 2 times 16 is 2 times 8 times 2 times 2. I think that's right. I need 1, 2, 3, 4, 5, 6. So let's try it again. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, times 2 is 64. Holy cow, a lot of 2's. And then times y. Okay, so there we go. We've written them in their lowest terms, and now we think about what they share. Okay, well, they all share a 2. They all share another 2. These two share a 2, but unfortunately we're done with 36. There's no 3's. They don't share an x or a y. So look at this. It's 2 times 2. And so, oops, again, I got ahead of myself. 2 times 2 is equal to 4. 4 is the greatest common factor of those 3 terms. All right, well, let's take it one step further. And this will be, I think this is kind of where it all comes together. So look at this. We've got 6x to the 5th. So we got to, we can have an x with an exponent on it, and then 30x to the 4th, and then 12x cubed. All right, here we go. Let's write them in their factored form. So 6 is going to be 2, and I'm going to use dots here again because I've used x's. So watch, it's 2 times 3. And then watch this. That x to the 5th is going to be times x times x times x times x times x. 5 of them. Okay, 30 is going to be 2 times 15. And 15 is 3 times 5. Okay, so 2 times 3 times 5. And then watch, times x times x times x times x. That's for the x to the 4th. And then 12 is 2 times 6. And 6 is 2 times 3. And then times x times x times x. All right, what do they share? Well, they all share a 2. Oh, look, they all share a 3 in terms of numbers. I'm done with the numbers. And then watch this. They all share 1x. They all share 2 x's. And they all share a third x. But that's it. They don't share any more x's. So here we go. The greatest common factor is going to be 2 times 3. And then it's going to be times x times x times x. So that's 2 times 3 is 6, and then x times x times x is x cubed. So that is the greatest common factor that all 3 of those terms share. Okay. Oh, I did one more. Sorry, I thought I was done. Let's do this one. Oh, because there can be more than one variable. So here we go. Let's try this one. 6 x to the 5th y squared, 30 x to the 4th y, and 12xy cubed. And notice I used the same numbers in this one, so I'll just quickly write them down. 2 times 3, 2 times 3 times 5 will give you the 30, and 2 times 2 times 3. So the numbers were the same. But now look at, let's do our variables. Well, this top one will be x times x times x times x times x. So that's x to the 5th. And then times y, x to the 4th. So that one will be times x times x times x times x, 4 x's times y. And then the last one is times x times y times y times y. Okay, so here we go. Let's get the common factors. Well, we've already seen that the 2 and the 3 are common to each. They all have an x, and they all have 1y. So the greatest common factor is 2 times 3 times x times y, or 6xy. That's what's common to each of these terms. Okay, now again, I know a lot of you are going to go, man, that's a lot of writing that you had to do there, and I think that you'll get better at just doing it by inspection, and I fully expect you to do that, but I just wanted to show you this method in case you need to do this for the first few to get used to it. Okay. Well, here's an example of how we use the greatest common factor. We'll do a couple of different examples here. So look at this. If you have a polynomial, so notice that it has 3 different terms, if you want to factor it. Okay, so in other words, I want to pull out the greatest common factor from each of these terms. So I'll look. Let's work on the numbers first. 9, 12, and 6. Well, I know that I look at the smallest number, 6, and I know that 6, it goes evenly into 12, but it doesn't go into 9. So then I break 6 down into 2 times 3, and I know that the 3 goes into each of them, but 2 doesn't, obviously. So here we go. I've pulled my number out. And look where I'm going. I'm going to be pulling a number out, and now let's work on the variables. So look at this. I've got x to the 4th, x cubed, and x squared. Well, it's always the lowest one. So look at this. X squared can come out of each of them. And then look at the y's. We've got y to the 4th, we've got y squared, and we got y cubed. So y squared is the smallest one. So there you go. That's the greatest common factor of those 3 terms. And then I just have to write in the brackets what's left, what I'd have to multiply to get back to the original term. So here we go. So I'd have to multiply this times what? Well, from a number standpoint, I'd have to multiply it by 3. From an x standpoint, I'd have to multiply it by x squared, because remember with exponents, we add the exponents. So x squared times x squared would give me the x to the 4th. And then for y, it would be y squared. So there you go. If I multiplied this times this, I would return and get my first term. Okay, let's do the second one. So plus 4, because 3 times 4 is 12. Okay, x squared times what would give me x cubed? Well, that would just be x, because remember it's x to the 1 and you add exponents. And then look at this. I wouldn't put any y term here because I don't want to add anything else to the 2 because I know that's where I'd end up at the y squared. So look at this. This times 4x is going to give you that term. And then finally, minus 2, because 3 times minus 2 is the minus 6. Look at this, no x term because I want the full x squared. And then I would write y, because when I multiply this times this, I get the negative as well. Don't forget that. I get negative 6x squared y cubed. Okay, so that's a good example of using the greatest common factor to factor a polynomial. I've pulled it out and then I've shown what's left in the brackets. Well, sometimes I'll show you a couple of more examples because these are similar questions that you'll have for homework. So in some cases they put a box there to say, well, what would you what would go into that box? What would be in that box so that when you multiplied it by the box, you end up with this term? Well, let's think about it. Well, what would I multiply by 3 to get negative 12? Well, in the box, I'd have to have negative 4, because 3 times negative 4 would give me the negative 12. Okay. What would I put in the box that when multiplied by 3y cubed would give me the x cubed? Oh, well, I need all of it, so I'll put x cubed in there. And what would I put in there to go from y cubed to y cubed? Oh, I don't need any y's. So there you go. That's what goes in the box. Let's try another one here. Here we go. So what would go in this box? Well, in this case, what times negative 5 would give me 30? Okay, well, negative 5 times negative 6, because a negative times a negative is a positive. Okay, and then m squared times what would give me m squared? Oh, I don't need an m term. And n times what would give me n cubed? It's n squared. So that's kind of they're getting you to guess what was missing. And here's another one. I thought this one, just for you guys to see a few examples. What would the box have in it? So that when you multiplied, and listen to this, you've got to use the distributive property. So when I multiplied the box by 4x squared, you get negative 24x squared. And when you multiply the box by y, you get negative 6y. Okay, well, let's try this. Well, I'm going to come over here and say this is what would be in the box. Well, 4x squared times 4 times what would give you negative 24? Okay, well, that would be negative 6. And then what times x squared would give you x squared? Oh, good, I don't need any x term. All right, let's see if it works for the second term. So negative 6 times y. Oh, good, yeah, it's negative 6y. So in this case, the box is just a number. It's just negative 6. Okay, let's try this again for this one down here. And it says 9a cubed times something will give me 2 different terms. So in this case, the box actually is going to have 2 terms in it. Okay, so here we go. 9 times what would give me 45? Well, 9 times 5. And a cubed times what would give me a to the 4th? Oh, just a, because you add the exponents. And then 9a cubed times what? Or 9 times what would give me negative 54? Well, that is negative 6. Okay. 9 times 6 is 54. And 9 times negative 6 is negative 54. And look, I don't need any a's because the a cubed is already there. So there you go. That's what was in the brackets. And you can, if you want to double check it, look at this. You can just come down here and try expanding it. I'll go 9a cubed times 5a minus 6. Well, let's try expanding that. If I multiply this times this in the distributive property, you multiply it by the first term. 5 times 9 is 45. And then a cubed times a is a to the 4th. And then 9 times negative 6 is negative 54, and then the a cubed just comes along. There you go. So it does work out. All right, finally, you guys, back to quadratics. Now, a lot of your homework will look like what we've practiced so far, like with these ones that aren't quadratics. Like a lot of you are going to say, well, Mr. Webster, nothing you did so far has x to the 4th or y 4th or x cubed. You're right. And so let's go here and just show you how these GCFs work with quadratics. And I got 3 little examples here because we're going to want to, the first step in factoring. And so let me go right back to right back to the first slide, which is we're trying to go from standard form to factored form. And the first thing that you're going to want to do is make sure you've pulled out the greatest common factor. So look at this. What is the greatest common factor of 3x squared and negative 6x? Well, from a number standpoint, the greatest common factor is 3. 3 goes evenly into 3 and 6. And look, x goes evenly into x squared and x. And what I would multiply by, well, 3x times what? Oh, times x would give me, when I did this times this, I get 3x squared. And then 3x times what would give me negative 6x? Well, it would be minus 2 would give me the 6, the negative 6, and I don't need an x term. There you go. So that times that gives you the negative 6x. So this is how we use the greatest common factor in quadratics, is we use it to pull out what's shared. Let's try this one. Okay, so here we go. Now, with this one, a lot of you may say, well, Mr. Webster, you could simplify this right off the bat because the 8x and the negative 4x are like terms. And you're right. So watch what I would do is I'd go negative 12x squared plus 4x. So I've taken care of my like terms. Now, these two I can't combine, but I could do a common factor. And look at this. 4 goes into them both evenly, and so does x. So 4x times what would give me the negative 12? Well, it would be negative 3x, because remember, an x times an x is x squared. And then 4x times 1. There you go. You've taken out the factor. Now, this one's a little bit weird, but I think it's good to see it. So you may say, well, boy, that doesn't look like it's in standard form. And you're right. But look at this. Do you agree with me that technically this is one term because it's 5x times x minus 2, and this is one term. It's 3 times x minus 2. So we got two different terms. And what do those two terms have in common? Well, look at this. They both share x minus 2. So I could pull x minus 2 out of both terms, and then I'd have to multiply it by 5x minus 3. Because if I took this term and multiplied it by 5x, I get this. And if I take this and multiply it by negative 3, I get that. So it's a little bit of a tricky one, but that one's interesting. I can pull out a bracket as much as I can pull out individuals. Okay, so there you go. If you can try some homework questions here, I've got the homework questions all at the end here, and I've got the answers on the last sheet. Good luck, you guys.